Hello, this is Dr. Prasad Kodielam with the class on the renewable energy resources. Some pending topics. Anyhow, I will be taking all the topics. I'm only giving the notes here. My video is not there, only my voice is there. So, this is actually module 4 and 5 storage of energy, introduction to pumped hydro, compressed air, flywheel, superconductor, superconductor magnetic, supercapacitor, batteries in which lead acid, lithium ion batteries, hydrogen fuel cells, and their merits and demerits are to be discussed. So, introduction to energy storage, the need for energy storage. Why we need to store energy? That we know it right now, because what when the continuous energy supply, when it stops, we cannot predict if anything can happen. Some interruption can happen, but we need a continuous energy supply to run almost all our electronic devices. So solar and wind energy production, it fluctuates it depending upon the weather conditions. So energy storage allows us to capture excess energy produced during the peak generation periods when we are using the solar or wind energy, not the normal energy supply that we are using as such. Where places where solar and wind energy production is used, only those type of renewable energy are used. Such cases, if you have a energy storage device connected to that or energy storage system connected to that, during the peak hours of generation of the electricity by those renewable energy resources, we can store some of the energy. Those can be it can be stored, and it can be released when the solar is not giving electricity, or the wind energy production is not there. That time we'll get it, and once they start working, means once sunlight comes, solar panels start working, or when the wind comes and wind turbines start working, such times, till such situations, such conditions, it will work. So that is the meaning of the need of energy storage devices. Now, types of energy storage technologies. There are so many technologies people are trying doing it, trying to replace the existing system of energy supply with renewable energy resources. They need this type of storage technologies. So many are there. Some of them are discussed here. Pumped hydro storage, battery energy storage system, compressed air energy storage, flywheel energy storage, thermal energy storage, or some of them which is discussed. We will discuss one by one in detail. Therefore, I am not reading this small sentences which is given. Only introduction is given. Detailed is there in the coming notes. So the future of energy storage. So energy storage, it is very rapidly evolving field, and there are so many research and development is efforts are going on, and the focus is there to store more energy with the minimum space, replacing the existing material with new materials. Even whatever the battery that we use in our laptop or the mobile, most of the space it is covered by the energy storage, the battery. If further the battery size can be reduced, we can further reduce the size of the device. So okay, so such research is going on, and even some of the energy storage devices that you are explaining here is of a building size, not a smaller battery and all. So advancement in battery technology, such as the solid state batteries and new battery chemistries needed to be understood, so that more number of electrons can be stored in a given space. Storing electrons is what about we are calling as the storage of electricity or energy. Okay, so moving to the pumped hydro storage. Pumped hydro storage, it is a well established and efficient method for storing large amount of energy. It functions much like a giant battery, using a basic principle of potential energy and gravity. Okay, so working principle will see energy storage phase, that is pumping stage. During the periods of low electricity demand, the excess or the surplus energy from the grid. Grid means from where the solar energy panels or the wind energy panels or the tide wave energy, from there it is connected to the electricity supplied to the villages or town, or that line connection we call it as grid, where it is getting supplied. Okay, so the surplus energy from the grid, from where it is going, uh, uh, that is used to power the pumps. So these pumps move water from, pumps means normal pump only, water pumping pump. Okay, so these pumps move water from a lower reservoir to a higher reservoir, essentially storing the electrical energy as gravitational potential energy in the elevated water. So using the electrical energy generated by the solar panels or by the wind turbines or any similar type of renewable energy resources, that electrical energy is converted into gravitational potential energy. Okay, now we'll see the figure. Okay, so from the low reservoir spaces, whenever we have excess energy, the motor is run and the water is pumped to a higher level, and where it is stored as a potential energy. A high potential energy is there because of the gravitational force, because it is in a little higher position. So that what the working principle of storing phase. Now the generation phase, or the turbines, are used when electricity demand peaks. The stored water in the upper reservoir is released. It flows downhill through the penstocks, or the large pipes, and drives the turbines, which in turn generate electricity. This electricity is then fed back into the grid to meet the increased demand. That means when we need the energy back from the storage system by using turbines, then electricity means when electricity demand is peak, when we need electricity is not produced, but we are in demand of electricity. When it is in peak position, then the stored water in the upper reservoir, it is released. So it flows down the hill through the large pipes, and when it flows through the pipes, or when it flows through the penstocks, it drives the turbines. And when turbines are running, or it is working, we are getting the electricity. So this electricity is then fed back into the grid to meet the increased demand. That means whenever we need electricity, the water from the upper reservoir is allowed to flow through this pipe and makes this turbine to rotate and get the electricity. Now components, the components of this energy storage system. We have upper reservoir, we need a lower reservoir, we need the penstock, that is the pipe to carry the water, we need a turbine, we need a pump to pump the water, we need a generator or motor which functions both generator and producing electricity. Okay, so all the options are given there. Now the merits and demerits: high efficiency, the round trip 70 to 85% means the energy required to pump the water, and whatever energy we are getting back, that percentage, if we are using 100% to store water, we are getting up to 85% efficiency back. Large storage capacity, it can store energy for days or even weeks. Long lifespan, facility can last for decades. Demerits or limitations: it requires a specific geographical feature, means it needs mountains with suitable reservoirs. High upfront capital cost is there to set up this, making a dam like structure, or covering, making it leak proof, or pipe connections, generator, lower reservoir tank. All this, it consists of a capital cost. Initial cost is very high. Can have environmental impact on local ecosystem. It can create some impact because we are filling a large area with the water. Large area means not a small tank, and a big area we are covering and filling with the water. So that will affect the normal life in that area. So the ecosystem is getting disturbed from the normal setup, and that is another demerit, or yeah, the demerit of the system. Okay, I'll cut this video here. I'll take another one for compressed air storage.